Hi everybody and welcome back to the A&P Bible. Today we are learning about types of bones and types of joints. If you missed my previous video on bone functions and what bones are made of, please go back and watch that as we do layered learning. It'll be easier to watch this one if you do that. Okay, so types of bones. So we're not just made up of one type of bone, and we're not all long bones. Our whole body isn't made out of long bones, because otherwise we wouldn't look the way that we do. So we're made up of an array of bones, and we're going to go through them now and where they're found. Before we do, let's get into what we're going to learn in the next 7 to 10 minutes. We're going to be able to understand the different types of bones. We're going to be able to give examples. We will be able to list the different types of joints and where they are found. We're going to be able to explain which joint carries out which movements. If you're unsure of movements, go back and watch anatomical terms with me. That will clear a few bits and pieces up. It's also a really nice recap. Okay, so straight into it, long bones. Example of a long bone is the humerus, which is this bone here, the long bone of the arm. It's a nice strong bone. It has epiphysis at either end, which is the head of each bone, and a diaphysis in the middle. Long bones, this is really important. When I do this, you know what this means. It's a multiple choice question that usually comes up. They are levers that allow movement. So they're levers that allow movement. So long bones are levers that allow movement. Examples: femur, tibia, fibula, humerus, radius, ulna, phalanges. Everybody gets confused with phalanges. They're small. They're small in size, but in structure they're the same as a long bone. They have an epiphysis at the top, an epiphysis at the end, and a diaphysis or a shaft in the middle. So finger bones are long bones. Don't get confused with that. Next type of bone, short bones. Short bones are found in the carpals, in the wrists, and also in the tarsals, in the ankles. They're very strong and compact, and they don't allow for a bundle of movement. Side to side, very minimal. Forward and back, yeah, we have a little bit of movement there, but again, very little movement is required here. And I just said tarsals and carpal bones. We will need to learn, depending on what syllabus you're doing, the names of all of these tarsals and carpals, but that's coming soon in the next video. Flat bones. Flat bones are also known as protective type bones. They either shield something or they try and encage something, usually organs or something important like the brain. So an example of a protective bone is also known as the skull. Scapula is also the shoulder blade, so that nice smooth flat bone here that can rub off the back of the rib cage with not a lot of friction at all, again protecting our internal organs at the back of the body. Ribs, if someone punches me into the ribs, they're not going to damage my lungs, hopefully not. They're not going to damage my lungs. Again, another function of the skeleton is protection, so the ribs act as that as well. If you look at them, or if you look at an example of a skeleton that's hanging up, you'll actually see them. They're really, really, really nice and thin. They're nice and smooth, and they're known as flat bones. Pelvis, the pelvis is also a flat bone. So if you look at the pelvic bowl or the pelvis bones, we call it like a little pelvic bowl. You'll see again, if you're looking at an example, that they're really, really, really smooth. So skull, scapula, ribs, and pelvis are flat bones. Irregular bones are bones that don't fit into any other category. They're not common around the body. They're irregular in shape. Really good example: the mandible in the face. Look at the little picture I have up here. Like, look at the shape of that. That is so irregular. Like, that doesn't fit into anything. It's not a flat bone. It's not a short bone. So it's also known as irregular bone. Another irregular bone is the vertebrae. So you have 33 vertebrae, and they're all irregular. They don't look like anything else, and they're obviously there for a function. This function doesn't need to happen anywhere else in the body. Either with the spine is there for a massive amount of reasons. Protection is obviously pinnacle because it's protecting the spine. So the spine bones are the vertebrae, also known as irregular. Sesamoid bones. Comes up in multiple choice questions all the time. What is a sesamoid bone? Bones with tendons. Learn this off. If you don't learn anything from today, learn this. Sesamoid bones are bones with tendons, okay? Tendon's job is to join muscle to bones. If you're doing a PT course, you got to know this. This is so important because it's so common in injuries. Your physio will also correspond with you as well, or your osteopath or whatever. And they will say like, oh, the sesamoid bone, or you need to know this, guys. So bones with tendons are sesamoid bones, and they join muscle to bone. 2 examples in the body. Now, I won't get too heavy on this, but it does annoy me. Depends on what anatomy and physiology book you're reading. One may say there's only the patella, which is the kneecap. So they might say that. Or another might say the patella and the hyoid, which is at the base of the thumb, which I put a little diagram up here. Learn both, okay? Just learn both. You'll find in some anatomy books there might be something really, really tiny that's in one and not in the other. Obviously, it's corresponding to a syllabus, but sometimes there can be small little things like that. But it's important you cover everything, okay? So patella, which is the kneecap up here, which is surrounded by tendons, and the hyoid, which is at the base of the thumb, okay? There's the different types of bone. Easy. We'll go through a recap again in a second, but moving on, we need to talk about the joints because the joints connect different bones to bones, okay? So a joint is a point where 2 or more bones meet even. So 3 types of joints we need to learn. Fibrous or immovable joints, which are almost like fused. So look at this skull. See, when you go on to watch the next one, you learn about all the different bones of the skull and bones of the face. But the bones of the skull are actually fused, but they are called different things in different areas. So you've like the temporal, the occipital, etc. But don't get too worried about that now. But just know that they are a fibrous or immovable joint. Cartilaginous, also known as semi-movable. This is a really good example of a cross section or just looking down at a few vertebrae. So this is the spinal column. Here is the spine running up through the middle and the vertebrae protecting it, and then white and grey matter here. In here. They're also known as cartilaginous or semi-movable. So yeah, we do have movement there. We can do flexion, extension. There is a little bit of movement, but I'm not super mobile in that area. Then you have synovial. Synovial is freely movable. Synovial allows me to do this, and if you could see the lower half of my body, my knee would come up and come all around the way of my pelvis. Doing a circular motion or doing circumduction type movement, and that's a synovial movement, a freely movable joint. So if you like graphs and you're very visual, you can take pictures of this. If you don't, please don't worry about it, but it does give you an idea of what they actually look like. So obviously this is not based on what they actually look like, but it's going to give you a really good visual idea so you can understand how the joints fit together and how the bones fit together. So the joint type, hinge, the movement, flexion extension, example, elbow. What also does this? The knee. Okay, so the elbow and knee do flexion and extension through a hinge joint. Hinge. Just think of a door opening and closing. It only goes one way and the other. That's it. Open the door, close the door. Hinge joint. Pivot. So rotation of one bone around another. So the atlas and the axis, they're at the very, very top of the vertebrae. So the pivot joint, literally just a small little bit of movement there of the atlas and the axis at the very top of the spine. Just looks like this. Ball and socket joint is what we talked about a while ago. It allows me for circumduction. It's found in the shoulder and it's found in the hip. Now obviously it does an array of movements because it's freely movable, so it can move in loads of different directions. So do just pay attention that it does have quite a lot of movements. I'm not going to bore you too much with that, but do be aware that that's there. Take a photo of it if you have to. And then we have a few more. Saddle joints. Saddle joints is only found in the thumb joint. So flexion, extension, adduction, circumduction. So that's your little thumb joint, saddle joint. Condyloid joint, flexion, extension, adduction, circumduction, flexion, extension, adduction, circumduction. Oh. Also found in the metacarpals. So you have your carpals, then your metacarpals, and then your phalanges. So in the wrist joint, the metacarpals and the metatarsals as well. That part of the foot are the ankle. Gliding, intercarpal then, also known as the wrists. So here, just these tiny, tiny bones in here. If you're doing beauty or holistics, you will need to know all of the names of these little tiny, 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 tiny bones in here. And this is gliding. So it's pretty, we don't have a bundle of movement here. And that's the intercarpals or the intertarsals. Sorry, just the intercarpals, not the intertarsals, because that's the foot and we have a bit more movement there. Okay, it's quiz time. So now I am recapping on my previous one, but if you didn't watch the previous one but you're watching this one, you should definitely know the answers to this anyway. So let's move on. The skeleton has how many bones in the body? So the skeleton, how many bones of the body does the skeleton have? It has 206 bones. The axial skeleton supports the blank, blank, and trunk. So the axial skeleton supports the head, the neck, and the trunk. Are the skull, neck, and trunk. So if that's the axial skeleton, what's the skeleton called that supports the limbs and the girdles of the body? It would be called the appendicular skeleton. Then name 2 types of bone tissue. We spoke about this again the last one. I'm just doing a recap so you guys are on the ball. And the 2 types of bone tissue in the bone are compact and cancellous or spongy bone. This bone tissue is found at the end of long bones. The end of long bones, or the head of long bones, is also known as the epiphysis, and the bone that's found in here is compact or spongy. Which one? Spongy or cancellous, isn't it? Compact is found in the shaft or the diaphysis. Name the 5 types of bones and where are they found? Okay, let's go. The first one, long bones. So long bones are found in, give me examples. Excellent. Humerus bones. Remember, what's an unusual type of long bone that I was talking about? The phalanges, isn't it? Also found in the femur, the tibia, the fibia, the ulna, the radius. That's your long bone. Short bones found in the wrists are the carpals and tarsals. Irregular bones, the mandible and the vertebrae, all down the back. Flat bones, bones of the skull, bones of the scapula, bones of the pelvis, bones of the rib cage as well. Did I mention all of them? I think I got all of them. Cool, and I hope you did too. Okay, let's go through some multiple choice questions. I'm going to start sneaking these in here as well. Which joint allows for flexion and extension and is found in the elbow and the knee? This is the elbow. The joint that allows me to do this is like a door. It opens and it closes, and the door is hooked onto what? Hinges. Hinge joint allows you to do that, number C. The joint found in the shoulder and the hip is loads of movement. It's freely movable. It's called a ball and socket joint. Also found in a synovial. It's synovial because it's freely movable. Ball and socket joint. What type of bones allow for movement? So remember a while ago I said something bones allow for movement. I said something bones are levers for movement. Something bones are levers. Think about L. L for lever, L for long bone. It's a D. And the study of bones is also known as, this is in my other PowerPoint because I've seen people get this wrong before, but that's okay, that's why we're doing it now. C, osteology. So the study of bones is known as osteology. Which one of the following is an example of a long bone? Oh, I just did this one with you guys, but I'll leave you answer it anyways. So you have carpals, which are the wrist bones, the ribs. The ethmoid will be on my next PowerPoint as well. It's the bone on the in the skull or in the face even. And the phalanges are also known as the finger bones. And I spoke about this already. It's the long bones in the phalanges. Which one of the following is not a function of the skeleton? So protection, that's a definite, isn't it? Support, that's a definite. Heat absorption or movement. So it's definitely movement, so it's C. It's not a function of the skeleton, it's heat absorption. And that's it. So now you know the different types of bones that are in the body, and you can give examples of which bones that they are. You can give examples of which type of joints are in the body, and you can list the different types of joints and their movement. So flexion, circumduction, extension, abduction, etc. So that's it, guys. Good job. Well done. Make sure that you're recapping if you are learning. If my voice is annoying you, need to write stuff down, just leave me play in the background and design some mind maps if this doesn't work for you. Remember, just find out what learning type you are and then start studying that way. Maybe you need a mix of flashcards as well for just your memory on top of my PowerPoints. Remember to double check your syllabus as well so you're covering everything. Otherwise, good job. Make sure to go back and keep recapping all the rest of my videos and keep building on your layered learning. Well done, guys.